Session. We're going to start with Devops with Django, Docker, and Gitlab with Luke Spademan. We're going to have 5 minutes at the end of the session for some questions from the audience.
Thank you. Yes, I'm talking on some hobbyist level DevOps with Django, Docker, and Gitlab. I'll be walking through an example just so you have just a solid thing you can use to, how everything works together. So first of all, who am I? So my name is Luke Spademan. I'm a student. I just started doing my A-levels, so I'm studying maths, further maths, computer science, and physics. I'm at Luke Spademan basically everywhere, and I gave a talk on micro:bits and Raspberry Pis last year. So, what is DevOps for those people who don't know? I'm bad at describing things, so I looked at Amazon Web Services definition. DevOps is a combination of cultural philosophies which increase an organization's ability to deliver applications at a high velocity. And it basically, if you can do things which make things easier for you. So what are the benefits of automating a lot of tasks? So first of all, you can save time in the long run. It stops you deploying broken code because then you have happy users, or if you're a hobbyist, you just have happy yourself. And it's satisfying when it works, and as a hobbyist, I think one of the most important things is to be satisfied with what you're doing and what you do. You are a hobbyist because you want to learn more and learn about new technologies. I'll quickly go over what Docker is for people who aren't aware, and yet again I stole a definition from Wikipedia. So Docker gives you operating system level virtualization, also known as containerization. So for people who don't understand what that means, it basically gives you a sort of virtual machine type thing which has everything you need in it so that your code can run anywhere on any operating system or platform as long as it has Docker installed and you don't need to worry about any other dependencies. So it makes your life great. So let's make an example project, because that's what we like to do. So we're going to make a very simple Hello World Django application to get all of this working. So first of all, we're going to want to use pipenv, because I don't like pip anymore, because pipenv is better. So pipenv is like pip, but instead of having to manually add your dependencies to your requirements.txt file, it'll automatically add things to your pip file for you, and it does a lot of things a lot better behind the scenes, which I'm not going to go into. Then you want to make a project folder, and in there you want a source folder, and then you just want to create a virtual environment with probably Python 3.7 now, but I did this example project a while ago. And then you want to install Django, GUnicorn, and that weird thing I can't pronounce. So GUnicorn stands for Green Unicorn, and it's a Python gateway interface thingamajig, which we use to run our Django code, and the last bits for connecting to our Postgres database. And then you want to enter your virtual environment and start a Django application in the current directory. And then we will need to, because we're keeping our source under version control, you don't want to use some of Django's default settings. You don't want to have your secret key declared in your settings file. I found this code somewhere on the internet. I don't know where exactly. But basically, you just want to see if the secret key is already declared somewhere else. And if you get a name error, you want to see if there's a file called secret.txt. And if there is, read the secret key from it. But if there isn't, let me scroll down. There we go. You can generate a random secret key and write it to a text file for future use. And yeah, that's basically what is there. What else? So also, we want to be able to know if we want to run code with debug on or off. So we'll check if the Django debug environment variable is anywhere. And if it is, we want to run with debug being true and allow access from localhost and basically anywhere, because it's a debug thing. But if debug is false and you're running in production, you only want access from your particular domain. A couple more things we need. So if debug is true, you can just use a SQLite database, then that makes it easier if other people running your code say they don't have Postgres installed and don't want to set up a Postgres database, because that can be quite complicated. And then, but if debug is false, we can have the default Postgres setup. What else do we? So we need to just add the static root section to the bottom of your Django settings, just so we can have all our static files in one place, and it's easier for them to get served and stuff. I don't know. And then we want to test, see if all this works. So you want to make sure you're in the source folder. You want to enter your virtual environment, and then make all your database migrations and run the server, and you should get the lovely Django, everything worked, you didn't misspell anything screen. So now we need a Hello World, Hello PyCon UK application. So we just want to create a new Django application called Hello World, and we want to just in the Hello World URLs file, just when people go to the root, we want the index view to be like linked to. So we'll just make a simple view that renders the Hello World index.html file, and then you need to create that HTML file, and you need to create a couple of folders because creating folders is awesome. So you need inside your Hello World app folder, you need a templates folder. Then inside that templates folder, you need another Hello World app folder, and that's where you put all of your HTML for your app. So we'll just have a basic Hello World HTML file there, and then you need to install the app and include its URL roots in the project URLs file. And then we need to put this in a Docker container so your code can run anywhere. So we need a Dockerfile for Python, and we're going to base this. You should probably base this on the Python 3.7 Docker file, but this was a while ago. And you want to make a source folder in your Docker virtual machine container thing, and copy your pip file and your pipfile.lock to the source folder, and then install pipenv, and then install all of those dependencies you have. And then you want to copy the rest of your code to the source folder. You do it this way around, so that if you've updated other bits of your code but you haven't updated the pip file, you won't have to reinstall everything when you update like your Docker or your other code, which makes life quicker when deploying. So because we'll need a container for all our Django stuff, then a container for Nginx and a container for Postgres, we need to use something to keep all these containers together. So we'll need a Docker compose file, version 3. And so we'll have our Nginx service, which will use a Dockerfile to build that we're about to create. And it will need our web service we're about to create to work. And all network traffic on port 80 will be forwarded to its port 8080. And the reason you do that is because Nginx has a default configuration for network traffic that comes in on port 80. So just by port forwarding, it means we don't need to override the previous default configuration. Then we need the web service, which will build from the Dockerfile in the root of our project, and it will run a start project bash file, which we'll create in a little bit, and it needs the database service to work. And then the database service will just use the latest Postgres database image, and that needs access to the database file things, volumes, so it can all the other volumes, so like the Django can access the Postgres database, and then we need to declare the database thing there at the bottom. So we need our start Django file, and this will actually run all of the Django stuff. So we'll get some basic debugging information, check what's in the pip file, and then just do a pip freeze to see what's installed. You can remove that when you actually put this in production. This is just for debugging purposes. And you need to migrate the database and then collect all your static files and run the project using gunicorn on port 8000. Yes, that is correct. Then we need to create the Nginx Docker file, which we'll just base that on the latest Nginx Docker file that already exists. And we're about to make a directory called Nginx and a directory about to create called config, which will have our Nginx configuration in it. And that will then get moved to the right place in the Nginx container. And then we'll copy the rest of the code there because Nginx will serve our static files because I don't think Gunicorn does that. And we need to expose port 80 because that's what HTTP uses. So we need to create a folder called config and a folder called Nginx in the folder called config, then a file called django.conf in that folder. And we want to, here we're basically saying we're creating this thing called web, which will connect to the web container we created that has Gunicorn running on port 8000. And then we want to have our actual server configuration. So we can serve our robots.txt from the Django static folder and the favicon and all the static. So all our static files will be served by Nginx. And then when anyone goes to the root, we want to pass that to that web thing we just declared earlier, and we'll be listening on port 8080 because of the port forwarding thing we had to do earlier. So to test all of this works, you can just do docker compose build and docker compose up, and you should get a hello Python UK screen when you go to localhost in your web browser. But all of this isn't actually got anything automated fun happening for us yet. But to do that first, we need to put everything in a Git repository. So we can just initialize the repository with Git init. Then you need a Git ignore file, which you don't want any test databases to be included in your Git repository, and you don't want any secret keys to be in there because that would be a massive security issue. And because this is an open source project, you need a README file. You can put whatever you want in there. Probably you should put more than just a title, but this is a Rush project. And then you can push everything, and you'll be able to see on GitLab that you have all of your files. I'm using GitLab, and for all the DevOps things, I'm using GitLab's built-in tools for CI, which makes things a lot easier, in my opinion. So GitLab uses things called runners, which will then take your code and then run them. I don't know if that's why it's called a runner, probably. I don't know. Ask GitLab. So to use GitLab has built in its own default runners, which you can use for testing your own code. But actually, for deploying your code, you need your own, and you need a server to put your runners on. And then once you've got your server, you need to set up GitLab's repository from where you can install the GitLab runner package, and then you can need to register your runner with your project. You can have whatever server you want. I, for my example, had a Debian server, which worked. So if you want to make sure everything works, you should probably use Debian server. So you need to set up the GitLab repository. There's a long curl command which will just download their script which sets everything up for you. All my slides are available on my GitLab, so you can copy and paste that. I'm sure it's somewhere else it's in GitLab's documentation as well, so you don't need to worry about memorizing that or anything. And then you need to just install the GitLab runner, which is relatively simple. You just install the GitLab runner and then register the runner. And when you register the runner, you will need to use a token which you can get from your repository settings. So you go to the settings section and then the CI/CD section, and then there's a bit where you can expand the runners tab, and there's a little code you can type in which will do all the authentication-y things for you. And then you need to give the runner access to the Docker socket. So the cache bit is in the volume section of the runner's default configuration, and you just need to add the Docker socket stuff there at the end. And then you need to log in. So we will, our Docker images, because you've got Docker Hub that you can download images from. GitLab has its own Docker registry where we'll be storing all of our images. So you need to log into the GitLab registry with your GitLab account on your server, so it can then build and push all of them to the GitLab Docker registry. And then you need to start the runner so it can actually do all the running for you, which is simple as saying GitLab runner start. And then you need to start Docker Swarm. So Docker Swarm is what we'll actually be using to run all of our containers because you shouldn't actually use Docker Compose in production. And if you were doing this on a bigger scale, you probably wouldn't be using Docker Swarm anyway. It's only good for like small hobbyist projects or projects for very, very, very small companies who are going to move on to something else very soon. They need to advertise the IP address that it will be being accessed on, because most servers have more than one network interface and more than one IP address. They need to disable shared runners, so you don't use GitLab's default runners, because then you will have a lot of issues because their runners won't actually be able to deploy your code. And to bring all this together, you need what's called a GitLab CI file, and that just declares how all of this stuff will work together. And this is just very simple YAML. So we want to base it on the Docker Compose thing, because we're using Docker Compose for a lot of stuff, like all of our testing of code. So we're going to have 3 stages declared in this file: our build stage, our test stage, and our deploy stage. So we want to just, what do we want to do? We want to set up so people can see what the different, so our server will push the changes to those registry addresses, and we need to log into the registry from before it can do on any of the pushing. And then we need to set up the test stage, and that will just run all of Django's default tests through Docker Compose. We need our build stage, which will just build and then push everything. The tags Docker just means if you have multiple runners, you can assign the runners tags, and then only runners with the tag Docker will be able to run that stage. And then you have the deploy stage, which will just do the Docker stack, the deploy. So it will deploy all the code into production, and only master means that it will only deploy when you push code to the master branch. So you can just develop all your code on the development branch, and then it will get tested when you push all your commits. But when you push or merge with master, then it will actually get deployed. You need to update Docker Compose slightly, just so it uses the images from the registry, not images inside your repository. And you just change that for web and for the Nginx. The database stuff will stay the same. Then you push your changes, and actually it will fail the first time because your Postgres takes a while to set up, and then Django's like, oh, Postgres doesn't exist, cause errors. You just restart everything, Postgres will then already be set up, and Django will be able to see it. There's probably a way to do that sort of thing more elegantly, but if it fails, you just rerun it without changing everything, you know, the classic software developer thing. So, in conclusion, what have we done? We've reduced deployment issues. Now you can't accidentally deploy broken code or forget to install a package when deploying code, because everything is automated and done for you. It makes things easier for you in the long run, and you've learned about something new, and that's like your sole goal as a hobbyist. So I'm Nick Spademan. You can find me in all these different places. I have a URL shorten you can use if you want, and yeah, I'm at Luke Spademan everywhere. Does anyone have any questions?
Are there any questions from the audience? Oh, yes.
Can you do all of this with the free account on GitLab?
Yeah, the only thing I've ever paid for is a server. This can all be done with the free stuff on GitLab. Yeah, which is great. Any other questions? Yeah.
What was it like using pipenv versus what you used before to manage?
Pipenv, yeah. I really like pipenv. It works really well because you can install development requirements as well, which then won't get installed in production. And everything's more elegant. You can't accidentally forget to add something to the pip file or forget to remove something. And it creates the virtual environment for you. So you just say pipenv and Python, then give the Python version. It will automatically create the virtual environment for you, and then you just pipenv shell and it'll enter it for you. It does a lot of stuff behind the scenes, and I think soon that will become de facto for everything Python.
They're at the very back.
Hello.
You've been using GitLab for this. Are you aware of similar processes available on GitHub?
I think there may be similar things you can do, but I have no idea because I haven't used GitHub since it was acquired. Well, actually, my friend used GitLab before GitHub was acquired and was telling me I should move over because a lot of these things I've just shown you, and it's difficult to move over. But actually, they have a great import from GitHub thing where it imports all of your code, and it's lovely. Did you have a question? Okay. Any other questions? Yes?
Yeah, so you said earlier that you wouldn't use Docker Compose in production, you use Swarm instead. Can you elaborate on the reasons why?
Because Docker Compose isn't built to be used in production. It's like how when you run a Django application, you don't actually use Django's built-in web server because Django make web frameworks, not web servers. Yeah. And actually, if you were doing this as a bigger scale thing for a company, you'd be using like Kubernetes and all that fancy new stuff instead of this. Anyone else? No?
Okay, can we give another round of applause?
Oh, those are my stuff.